class. Today we're going to look at section 2.3, and basically the whole section is about word problems, and the first part starts off by translating. In the textbook, if you check out page 67, you're going to find a list of information, little sentences that have been converted into mathematical expressions. So we have the verbal expression, mathematical expression. So you can see that it goes through and it lists a lot for each different operation. I would suggest taking a moment and looking at this on page 67 of your textbook. Some of the popular ones that are missed are working with ones that say like 6 more than a number. So notice that 6 more than a number, we're adding 6 to something. And the thing that we're adding it to is a variable, some random number. Okay? Same thing down here. We have 2 less than a number. So notice that we're subtracting 2 from our number. Again, that's a common one that's missed, so be careful with that one. With multiplication, usually we do pretty good setting up these multiplications. Identifying the word of is a big one that you're going to see a lot. So you want to work with that. With division, same concept. The quotient, and then it tells us the order. So the 8 is going to be our numerator, and the variable is the denominator. Okay. So I would take some time and read over page 67, or if you do get stumped on some of these, underline what you're stumped on, and then go to this page and see if you can figure out, well, it's asking me to do plus a number. That's telling me just to do addition. Or it's telling me to a number decreased by. Okay, come here. That's telling me to subtract. So use this page as a reference as we go through. Remember, you can always pause me if you want me to slow down. Okay, so the first one we're just translating here means we're taking a written statement and we're turning it into a mathematical statement. And so let's start by identifying some of the parts. So we have the product of 8 and 16 less than a number. So what we want to do is we want to take this and convert it into an algebra statement. Okay, so we have the product of, so the product tells us that we're dealing with multiplication. So we have the product of 8 and, so we have 8 times the second part. The second part that we're multiplying is 16 less than a number. So that word and is telling me where the multiplication is occurring. I'm multiplying 8 and the statement of 16 less than a number. Well, 16 less than a number, so 16 less than a number. Well, when we're multiplying our 8 and 16 less than a number, if we just put a multiplication symbol here, then that means that only these two are being multiplied. So to represent that we're multiplying the entire thing, we're going to put this in parentheses. So let me write it a little closer together. So this is really 8 times the 16 less than a number. Okay. So the tricky part with this one is a lot of times we want to do the product of 8 and 16, so we just want to multiply those two together real quick. But you got to identify that this 16 less than a number is in the parentheses. Okay, so a little tricky. Let's look at one where we're using the variable x, and we want to write an equation this time, not an expression. So our equation is going to have an equal sign in our problem. So we want to go through and identify where our equal sign needs to be. So again, let's look at what we have. Okay, so it says if the product of a number and -4. So we have the product of a number and -4. So we already determined that product is multiplication. The two things that we're multiplying are a number and -4. So the product of a number and -4. Now the second part that we have is subtracted from the number. So this value is subtracted from the number. Again, the number is our variable. The result is, so the result is, that's our equal sign, 9 more than a number. So 9 more than a number. Okay, so see how we've broken it up into the different parts, underlining what works together and going through. Now we want to also find the number, so that means we want to solve this equation. So I'm going to go ahead and work this portion of it. So we have -x times -4. So that really gives me a plus 4x equals x plus 9. Well, 1x plus 4x gives me 5x equals x plus 9. Looks like I'm running out of room a little bit here, so we'll create a little more room. So we've combined our like terms here. Now we have x's on both sides. So we're going to subtract x from both sides. And that gives me 4x equals 9. And then to undo multiplication, we divide by 4. So that gives me an answer of x equals 9/4. So we have two parts to this one. We're trying to set up the equation, and then once we have the equation, we're trying to solve it. Okay. Let's get into some word problems now instead of just translating. Now we're going to have some value to our statement, and we'll work our way through. Remember, if I'm moving too quick, go ahead and pause me. And then whenever you're ready, you can catch back up. So the John Hancock Center in Chicago has a rectangular base. Okay, so there's the first thing. It's telling us the shape. Rectangular base. So I'm just going to draw a rectangle here. Okay. The length of the base measures 65 feet, less than twice the width. The perimeter of the base is 860 feet. What are the dimensions of the base? Okay, so we need to figure out what perimeter is first. So let's talk a little bit about perimeter, and then we'll come back to the rest of it. So perimeter means the distance around our shape. In this case, we're dealing with a rectangle. So we have a length, we have a width, we have another length, and we have another width. So the perimeter is equal to adding all of these up. Okay. It's also known as 2w plus 2l is the shortcut for the perimeter. Okay. So perimeter is just the distance around our figure. So we just add up all four sides. The shorthand of that is 2w plus 2l. Okay, so we have the perimeter is equal to 2w plus 2l. Now let's see what we know. It says the perimeter of the base is 860. So this is our P. So let's go ahead and drop 860 in. The other part that we are given is the length This is my L of the base measures 65 feet less than twice the width. So off to the side, I'm going to have the length is equal to 65 less than. So that means I'm subtracting 65 from something, and I'm subtracting it from twice W. What this does for me is if you look at our problem over here with our perimeter, we have W and we have L in our problem. So we have two variables. For us to solve right now, we can only work with one variable. So they give us a statement to replace L. So notice that the length is 2W minus 65. So all I'm going to do is, in my problem, I'm going to replace the L with 2W minus 65. Okay, so we've eliminated the L. The L is 65 less than twice the width. The advantage to doing that is now we only have one variable. And when we have one variable, we can solve. So let's distribute. So we have 860 equals 2W plus 4W minus 130. I have some like terms here. I'm going to combine those together. That's going to give me 6W. Now the plus 130, I'm going to add that to the other side. So let's add 130. And that gives me 0.99. The only thing we have left is to divide by 6. And we get W equals 165. So it's asking us, what are the dimensions of the base? Well, the dimensions, you need both length and width. Right now all we have is width. So here's part of our answer. To find the length, I'm going to use my formula that we created. Length is equal to 2W minus 65. And we're going to take that 165 and drop it in for W. So we have length equals 2 times 165 minus 65. Okay, sorry, I accidentally hit the pause button and solved the problem, but notice that we just multiplied the 330, then, or sorry, 2 times 165 to give us the 330, subtracted the 65, and then got our final answer. So when solving this problem, notice that we started with drawing the picture, labeling the parts, identifying what perimeter was, getting the formula for perimeter, and then started plugging in our information that we knew. We didn't try to jump straight to the equation that we are going to need. We went through the process of figuring out the formula we needed, how to get that formula, and then started putting our information in. So let's go ahead and look at another one that's similar. So go ahead and pause me and see what you can come up with for this one. Again, start with a picture and go from there. Okay, welcome back. Hopefully you took a moment to try the problem. Again, we're dealing with the perimeter, and we're dealing with a triangle this time. Alright, so let's go ahead and draw a triangle. It has a perimeter of 3,075 miles. The shortest side measures 75 miles less than the middle side, and the longest side measures 375. So the perimeter for a triangle is first side plus the second side plus the third side. Okay, so we're adding all three sides together. Okay, so let's see what we have. We know that the perimeter is 3,075. Okay, and we have the shortest side measures 75 less than the middle. Okay, so I have the shortest side, I'm going to call that S1, is equal to 75 meters less than the middle one. So we'll call this one the middle one. So we have middle one, we have the smallest one, and then we have the longest one. Will be our information that we use. Okay. So we've identified what S1 was. The other part it tells us is, excuse me, okay, sorry about that. I had a little cough come out of nowhere. Okay, so now we're going to look at the longest side. So in our case, we're calling that L. Measures 375 miles more than the middle. So 375 miles more than the middle. Again, we're calling the middle M. Find the lengths of the three sides. Okay, well, if we leave it our different variables, again, we have three different variables. We want to convert them all to one variable. And notice that both of these refer back to the middle side. It doesn't tell us anything about the middle side in relation to itself. That's the unknown value. So m equals m. So what I'm going to do is, where I see this S1, for the smallest side, I'm going to plug in m minus 75. I'm going to add that with the middle. Well, the middle we just called was m, plus the longest side. And we said the longest side was 375 miles longer than the middle. So m plus 375. So from here, we now have m involved in all of ours. So we can combine like terms, 1m, 1m, 1m. That gives me 3m. Sometimes it's helpful to circle or box them. So we have a minus 75 and a plus 375. So this gives me a plus 300. And it equals 3,075. Okay. So we're getting to the point where we all have one variable and we combine like terms. Now we're going to keep solving. Our next step is to subtract over the 300. So let's get the red pen. So we have minus 300, and that gives us 2775 equals 3m. And then we're going to divide by 3. And we get 925. Okay, so this is m, which is the middle. So now it's asking us to find the length of all three sides. So I have the middle one. To find the smallest one, we're going to plug in our value here. So the small one is going to equal m minus 75. Well, we know m is 925. So 925 minus 75, which should give me a value of 850. So there's the smallest side. And then the large side we know is the middle plus 975. So we have 925 for the middle plus 375. So that gives us 1300. Okay. So you can see that once you find one, you should be able to go back and plug in the value that you found and find the remaining two.